So, hi everyone, let's talk about alkenes today. What alkenes are, if we talk about the general formula is CnH2n. It's an unsaturated hydrocarbon. When we say it's an unsaturated hydrocarbon, what do we mean by that? That it possesses carbon-carbon double covalent bond. They are more reactive than alkanes, and the reason why they are more reactive than alkanes is because it's easy to break the double bond. And why is it easy to break the double bond? Because of the pi bonding that is involved in this double. So there are methods of reducing alkenes. For example, the first method is by cracking, and we are doing the cracking of what? We are basically breaking down the long chain hydrocarbons into small chain hydrocarbons. The HC stands for the hydrocarbons. The cracking can be of two types. Either it is catalytic cracking or thermal cracking. Now, what will it do? It will break down the large molecules into small ones. For example, decane, as I told in alkane part also. That alkane has how many carbons? It has 10 carbons, and it will can be broken down into hexane and butene. Means a compound with 6 carbons and a compound with 4 carbons. The other part is elimination reaction. Elimination reaction is another way of producing alkenes. I will redo this equation in front of you so that you can understand that what exactly is the process and how are we producing alkene through this. So what basically is the reaction? The reaction is that let's suppose you take a halogen alkane. And halogen alkane means, of course, one halogen is attached and the other one is an alkane or maybe alkyl that has to be a two carbon compound. Then we are treating it what? Sorry. We are treating it with what? We are treating it with sodium hydroxide. And we are producing alkenes. Now, how does this happen? So let's suppose if I've taken a halogen alkane that is chloroethane. Chloroethane means that there are two carbons, and with one carbon, if it's chloroethane, means one chloro ethane. So there's the halogen is attached on the first carbon. It will be reacting with what? It will be reacting with NaOH, which is sodium hydroxide. Now, this can be broken down as what? Na plus and OH minus. Chloride will be detached from here. So this chloride ion and the negative ion, they will combine together. Also, one hydrogen ion will be broken down from here. When one hydrogen ion will be broken down, this can react with this OH ion and form what? H2O. So we get a water, we get a halogen compound, and then we get an alkene. Now, this carbon lost chlorine, this carbon lost hydrogen. They both have to make one bond. So they make the bond with each other and they will turn into what? They will turn into alkene, a double covalent compound, double covalent bond compound. So that's how we get an alkene from elimination reaction. So you can practice these reactions for your further clarity. Dehydration reaction is another reaction through which you can produce alkene. And how is that possible? You are treating basically hot alcohol. It passed over what? Hot catalyst of aluminium oxide powder. So alkene is produced. Now alcohol does what? Basically alcohol loses a hydrogen or OH group. H2A is eliminated and it turns into alkene and water. This can be the ionic equation. This can be the ionic equation for any sort of this reaction where a hydrogen ion is reacting with hydroxide and turning into water. So how this reaction happens? For example, this is ethanol. Ethanol because there is a two carbon compound and an OH group is attached to it. Now OH will be detached from here, H will be detached from here. They both will have a double bond with each other. They form H2O and ethene. So basically, from each carbon, whatever the compound you are taking for the formation of ethene, one component will be detached and these two will bond with each other. So you can practice these ones for your convenience. You can practice these reactions for, I'll do one with you. See, when it comes to the reactions of alkene, there are multiple reactions of alkene which you will be studying. A very common one is the addition reaction. As I told you, alkene has many different sort of reactions, and there are quite a lot actually. So, for example, we have an ethene molecule. This ethene molecule can turn into multiple things, and that is because of the easy breakdown of double bond. Now, this ethene can be changed into what? This ethene can be changed into an halide. Number one. This can be changed into a dihalide, where the rest of the hydrogens are attached. Number two. This can be changed into halohydrin. Halohydrin means a OH group and a halogen is attached. This can be changed into this number four. It can be changed into an alcohol simple. Then this can be changed into an alkane. This alkene can be changed into alkane. These are sort of reaction. Number six, it can be changed into diol. It can be changed into carbonyl compound. It can be changed into number eight. It can be changed into cyclopropane. A three carbon compound. It can be changed into epoxide. It can do addition polymerization reactions. So I told you 10 type of reactions that alkene can do. So other than these 10 type of reactions, which are all addition reactions, and I'll tell you how those reactions are possible. This can do oxidation reaction as well. Now, what oxidation reaction is? See, in oxidation reaction, it can either react with cold KMnO4 or it can react with hot KMnO4. That's the first thing first. If it react with cold KMnO4, then it will change into what? It will change into diol. If it will react with hot KMnO4, it can change into aldehyde and carboxylic acid. So let's suppose I have an ethene over here and I'm treating it with cold KMnO4 in the presence of oxygen. So what I'll be getting as a result, I'll be getting a diol over here. And the purple color will change into colorless solutions. So if it's a hot KMnO4, it's a very harsh reaction. So if it's a very harsh reaction and I'm reacting it with ethene, which is a primary compound, then this will change into simple two carbon dioxides. If I'm treating it with hot KMnO4, it's a comparison of ethene oxidation with hot KMnO4 and cold KMnO4. Now, let's suppose I have a secondary molecule. Now, when I say I have a secondary molecule, it means two alkyl radicals are attached over here. It's not ethene anymore. Two alkyl radicals. Alkyl radicals means here it's a carbon compound which can be CH3, C2H5. Here it's a carbon compound can be anything. Now, if this will be oxidized in the presence of hot KMnO4, it will give me what? It will give me carboxylic acid. See, what is written over here, that really does not matter. Carboxylic acid means that it will give me this functional group. Now, what this functional group is, a carbon with a double bond of oxygen and OH. When this carbon will have this carbon with a double bond of oxygen and OH, which is COOH, then it's a carboxylic acid. And if I treat it with tertiary means three alkyl radicals are attached, then it will give me what? Ketones. And how ketones can be identified? It can be identified. One carbon is attached with what? A double bond with oxygen and alkyl radicals. So this is the difference. If I'm taking cold KMnO4, ethene can only react to it and it will give us diol. Hot KMnO4 primary, then it will burn and gives us carbon dioxide. Secondary will give carboxylic acid and then it will give us ketone. But before it gives carboxylic acid, it also gives us aldehyde. Do remember it. Now, what is aldehyde? Aldehyde means that first an oxygen and H will going to attach, then another oxygen will add over here and will change into carboxylic acid. So that's an example where it's a tertiary one. This carbon is attached with further two carbons, treated with the oxygen in the presence of hot KMnO4. So it is changing into what? It is changing into propanol. So this part will be detached, and here oxygen will going to be attached with this carbon, and it will change into propanone, and the rest of the carbon will turn into carbon dioxide and water. You can practice these equations. This is all the reactions of hot KMnO4, because in cold KMnO4 you will not get more variety, as well as hot KMnO4 will give you more types of reactions. So it's better to practice these reactions. You can always come up with the queries if needed. These are again a practice question, and that is to put the things on your hand in terms of writing the names. You can always write the names, draw the structures, and then you can check it yourself as well. There is a test which is called as test of unsaturation. Now, what does this test means? So if I have two test tubes, let's suppose test tube A and test tube B, and I've been asked to identify that where is alkane and where is alkene. All right, what I've been asked to identify where is alkane and where is alkene. Now, alkane is a saturated compound, while alkene is an unsaturated compound. So that is why this is called the test of saturation. It means you need to identify that where we have a saturated compound and where we have an unsaturated compound. So what I'm going to do is I'll add bromine water in both of them and both the test tubes. If in one test tube the color will remain the same, then this means that here it's alkane. Because as we studied in alkane as well, that alkane is highly unreactive, so it does not react. It reacts only in the presence of the UV light. So it will not show any reaction with bromine water. As far as alkene is concerned, so if bromine will react, that means it will lose its color, the red-brown color. It will become colorless. In the moment where in whatever test tube it will become colorless, that shows the presence of unsaturated compound, and that unsaturated compound here in this case can be alkene. So this is what we call the test of unsaturation, that comes very often. Then the question comes that why electrophile addition reaction can be done in alkene, or why an electrophile attached. See, electrophile is that species which has a positive charge. So it is because number one, the double bond of alkene is an area high electron density. So here it has a high electron density. And when we say high electron density, means the presence of a negative charge. So this negative charge is going to attract a positive, of course. That is why it attracts an electrophile, not a nucleophile. So this is the main reason because of which a double bond is attracted by an electrophile. Let's suppose this is an example. So beginning from here, this is an alkene molecule, which is propene because it has 1, 2, and 3 carbons. So let's suppose if I treat it with hydrogen bromide. Hydrogen bromide, if it will break with a homolytic fission. Homolytic fission means it will get charges. So it will get a partial positive charge. This will get a partial negative charge. This partial positive one will going to attack this carbon. This double bond will donate the pair of the carbon or the pair of the electrons, and it will get with charge. This carbon will get with charge, the positive charge. Because hydrogen is being attached over here. This hydrogen is attached over here. I repeat, this hydrogen is attached over here. Since this carbon, while breaking off from the bond, donated the electrons to this carbon, that is why it gets a positive charge. So whatsoever atom is going to donate electrons, it gets a positive charge. And since bromine is left, so bromide ion is left and it has a negative charge, so it will automatically be attracted towards this carbon, the positive one. And you will get a product which is 2-bromopropane, which will be a major product. There can be a possibility that, hydrogen will not attach with this carbon first. Rather, hydrogen will attach with the second carbon and the bromide ion will attach with the other carbon. So here, if I'm getting a 2-bromopropane, here I can get a 1-bromopropane as well. So this can be a possibility, but major product means the possibility of this above product is more. Where does it come from? This come from the Markovnikov rule, which tells us that this is a Markovnikov rule which explain, and it tells us what in addition reaction an electrophile react with double bond of alkene will add to the carbon to give the most stable carbocations. So it will attach to the carbon where the stability of the carbocation is the most. So this means the first carbon, if it attach and the other carbon become the carbocation, the stability there is more. So that is why we get a major product over here. Here we get the major product because here the stability of this carbocation is more. So this is what we discussed that in a double bond, this is high electron density area. This high electron density area can make a non-polar bond a polar one. Because the moment this will come closer to this, they will force, see, when I say non-polar means electrons are shared right at the center. No one will get a partial positive, partial negative charge. When they'll get a partial positive, partial negative charge, when electron is attracted, one of the atom to, attracted more towards one of the atom. So when it becomes to here, closer to this carbon-carbon double covalent bond, since it's in high electron charge density area, it will experience a force of repulsion. So this can get a positive charge, this can get a partial negative charge. And this is called what? Induced dipole. Because having a partial positive and partial negative charge is called dipole, or this is called polarity. So this will act as an electrophile and this will act as a nucleophile. And they will going to attack and break the double bond. That's how the reaction happens. So this is the detail in words. You can always pause the video and you can read it as a further explanation of what I've just explained you. This is one of the example. Let's suppose this is ethene. A bromine molecule came closer to ethene. And this electrophile is going to attack the double bond. First bromine will attach itself over here. The second bromine, which got -1, will attach with the positive one. As a result, 1,2-dibromoethane we will get. Simple words, a carbon-carbon double bond will break down. So if I'm adding a bromine, those bromine will be added in these two positions. Let's do it this way. If I'm adding a bromine over here, bromine can be added by simply the double bond will change into a single bond, and along with hydrogens, the bromine will be added. Here, hydrogens are attached. If I'm adding HBr, so along with other hydrogens, hydrogen and bromine will be added. So we were talking about the carbocations. So carbocations are what? They are positively charged atoms which have only three covalent bonds. This is primary and secondary and tertiary. Primary is the least stable. So means if the first carbon will change into carbocation, that will be the least stable. Secondary are the stable and tertiary are the most stable ones. So that is how that Markov rule is going to be applied. This is all in words explanation of what we have discussed so far. So you can always pause the video, you can read it, and this can be explained. I would like to explain the addition reaction as I told you earlier as well that it does the addition reactions. So addition reaction is possible with what? With this. Simply a double bond will going to be broken down. Along with hydrogens. If you are doing a simple addition reaction with HBr, so hydrogen and bromine will going to be added. So you will get a uh, bromoethane. Here is one dibromoethane. Here is a bromoethane. If you are reacting this one with H2O, then H2O will break as H and OH, and hydrogen and OH will be added. So this will be ethanol. So this is from ethene it changed into dibromoethane. From ethene it changed into bromoethane. From ethene it changed into alcohol. So I gave you those 10 reactions in the beginning. You can always go back and check that if you are getting a certain point, which means that you are reacting alkene in something, addition reaction is happening and you're getting that point. So if any questions, you can always drop in the comment and we'll get back to you. See you in the next one.